Good morning, everyone. Thank you for joining us. Welcome back. I'm Steve.
And I'm Scott.
Together, we are Backyard Musing Science and Technology Channel, the one you can trust. We're not experts, we're the messengers, and we're in Apple Valley, California.
We are, and we've got a really interesting couple of topics for you today. The first one we're going to do has to do with volcanic activity. So stay tuned.
We talked about this eruption before, but now scientists have analyzed it, and it's incredible. Pressure waves from the colossal 2022 Tonga eruption rippled through Alaska's crust, offering scientists a rare look into the state's deep subsurface. Atmospheric waves from a powerful volcanic eruption in the South Pacific in 2022 produced a seismic vibrations that reached depths of at least 5 kilometers beneath Alaska. That's 5 kilometers, about 3 miles. Yeah. This extraordinary event gave scientists a rare chance to explore the state's deep subsurface using an unconventional approach. Macpherson's research on seismic velocity to depths of 30 meters, or 100 feet, 2 kilometers, 1.2 miles, and 5 kilometers, 3.1 miles, was published in the journal Seismica on July 8th, 2025. Would you like to know more?
Yeah, and not just, we're going to talk about it later, but not just the fact that of the depth of this, of where they felt this, but the distance, right?
Yeah.
It's a long way. So Ken Macpherson, a researcher at the University of Alaska Fairbanks Geophysical Institute, and his team studied how atmospheric pressure waves interacted with the ground to measure the speed of seismic waves moving through Alaska's upper crust. By comparing the strength of the air pressure waves with the resulting ground motion, the researchers were able to infer characteristics of the underground materials, such as their stiffness, which influences how quickly seismic waves travel. Remember this from physics class, high school physics class.
So picture blowing across a bowl of Jell-O and then doing the same over a pan of brownie batter with the same force. The Jell-O would wobble while the brownies would barely move because the material is stiffer. Hunga Tonga's pressure waves have provided us much more information about how seismic waves propagate in Alaska, Macpherson said.
The explosive eruption of the Hunga Apai volcano in the kingdom of Tonga, and about 6,000 miles from Alaska. So that's. I mean, we don't feel seismic activity here. I mean, maybe it's a few hundred miles, maybe at the most. So that's pretty amazing.
Yeah.
Yeah, and this occurred on January 15th, 2022. The eruption's atmospheric waves were the largest known from a volcano since the 1883 Krakatau eruption. I don't know where that is. Where's Krakatau?
I don't know.
Okay.
Maybe that's the name of the mountain.
Maybe so.
Quote, Hunga Tonga was an unprecedented explosion in the instrument age, said Macpherson, who is with the Institute's Wilson, Alaska Technical Center. Continuing the quote, those pressure waves shook Alaska 6,000 miles away, which I just think is so remarkable. And many of those were long period waves and consequently shook Earth to a great depth.
A network of 150 co-located barometers, infrasound sensors, and seismometers in Alaska recorded the eruption's data used in Macpherson's research. I'm trying to think. That's got to be at least a couple time zones, right?
Yeah, maybe across the international time zone.
Yeah. Gaining information via air-to-ground coupling at a depth of 5 kilometers is uncommon. That's because the seismic waves produced through coupling usually have a shorter wavelength unless the power source is something really, really big. Obviously, in this case, it was really big.
So I'm thinking that with all those sensors, 150 of them, they're using the local Sasquatch population to help monitor those and, troubleshoot them.
Okay. And where did these Sasquatch go to school to learn to do this?
I don't know.
Read those.
They're elusive, man. I don't know.
Okay.
Quote, because the Hunga explosion was so enormous, the pressure waves that traveled the long distance to Alaska were still powerful enough to shake the Earth and were therefore ideal for a coupling study, Macpherson said. Ooh.
How does an atmospheric pressure wave shake the ground? And how can it rattle the ground 5 kilometers below the surface, you ask? Powerful pressure waves from a volcanic eruption or explosion create rapid changes in air pressure as they travel through the atmosphere. When these pressure waves contact the ground, they push and pull on the surface in a process called air-to-ground coupling that transfers energy into Earth's interior.
The energy transfers through a process described as Newton's second law, which states that an applied force causes particles to move by overpowering their inertia. That particle motion creates seismic waves containing mechanical energy in 2 forms: kinetic energy from the moving particles and elastic energy from the crust's temporary deformation as the wave passes through.
The velocity research can be an additional tool for seismic hazard analysis because wave speed affects the level of ground motion. Quote, if a propagating wave is in deep material and going fast, but suddenly hits a soft material, the conservation of energy says, well, I'm going slower, but I still have the same energy, Macpherson said. That means amplitudes get bigger, causing stronger shaking. So that kind of goes along with what you were talking about there, the jello and the batter.
Right. Yeah, the batter.
You still have the force, but it's not being released in the same way, right? So,
yeah. The way they put it is pretty cool.
Yeah.
Quote, just knowing those upper crustal velocities is good for seismic hazard analysis, he said. It's also good for network operators like the Alaska Earthquake Center and Sasquatch Center because they can accurately apply the crustal velocity beneath a particular seismic station to potentially increase earthquake location accuracy.
I think your cat is involved in this as well.
Yeah, he's right
I think
here.
he feels it.
He's one.
Macpherson's work can also be particularly helpful in tomography, a technique seismologists use to create 3-dimensional images of Earth's interior by analyzing how seismic waves travel through different materials. Tomography reveals variations in properties, such as density or velocity, helping scientists map the deep subsurface.
Quote, to do tomography properly, you have to do what's called a crustal correction because velocities in the upper crust are so much more different than those deeper velocities that you're trying to get at, he said. If you know something about the crust, you can apply a correction that improves tomography for tens to hundreds of kilometers.
All right, there you have it.
Yeah. So that's crazy. 6,000 miles away, 16,000 feet deep. Makes you wonder if it went down to the core and bounced up or if it just, along the crust.
Yeah, no, that's phenomenal. I wonder how long it took.
Yeah.
To get there.
Oh, yeah, that would be.
I think that's a key thing they left out of this. So.
Yeah.
Anyway.
All right, folks. Thanks for joining us.
See you this afternoon. Thanks.